In this lesson, we're going to examine the last part of rotational trigonometry. Here, we're going to try and determine the angles that are being used when we're given the ratio. So kind of backwards from what we did yesterday, where we were given the angles and had to figure out the ratio. So we're going to start with an example. And so each of the following would determine the measure of the principal angle and give an equivalent negative angle. So they're telling us that tan theta is negative root 3 in quadrant 2. When we draw pictures, quadrants refer to where that picture lies. It's kind of telling us where to draw our triangle. So the triangle goes from the origin, we make it with the x-axis. We're thinking about sirs, sixer, ticks. The fact that I'm given 10, and I'm actually given a fraction and I don't see it, y over x. So my y value is root 3, my x is 1. Now there's a negative sign there. We've talked about that negative signs can move around. It doesn't make sense to put the negative sign on the y because it's going upwards, but it makes more sense to put on the x. So we have to think about the fact that negative 3 over root 1 is the same as root 3 over negative 1. The x has to go in the appropriate spot. This looks like one of our special triangles. We know that 3 goes beside the 30 always, which makes this a 60. So if I want to figure out theta, theta is my answer from 0. Theta goes all the way to here. Now, it doesn't go quite to the end. That would be 180 degrees. We've stopped 60 before that. So theta has to be 120. The equivalent negative angle would be what if happens if we went backwards. So we've gone past 180 degrees, 6 degrees past. So we could also say negative 240. And we don't know which direction that this picture was drawn in. We'll try the next one. I've got cosecant theta, and they want me to draw it between 180 and 270. So 0, 90, 180, 270. It has to go here. Cosecant, again, we can put a fraction in there, is related to sine. It's the opposite of sine. So this is r, and this is y. So r is 2, y is 1. Where should that negative sign go? We can't put it on r. It has to be on y. Again, we have a special triangle, 1, 1, and, oh, not 1, 1, and 2. 1, 2, and we need a root sign there somewhere, right? So root 3, and it has to be negative because it's gone to the left. Beside a 3 always goes the 30. So what is my answers for theta? One answer would be if I started 0 and went all the way around, I've gone past 180, 30 degrees. So I'd have 210. Or if I went clockwise, backwards, I haven't reached 180. I've stopped 30 degrees short of that. So I could also say it's negative 150. So working backwards. The nice thing with these questions is we are told where to draw it. That's not always going to be the case. Sometimes we're just told the ratio. We have to think to ourselves, where can I draw this? So solve for theta if tan theta is 1. Now we know it's 1 over 1, and we know Sir Sixer ticks means y and x both have to be the same. So if I had to draw a picture, and both my things have to be the same, and they're both positives, that means I have to go to the right and up. 1 and 1. Well, that's a special triangle. These are 45s and 45s and 90. So I can say to myself, well, theta has to be 45. I didn't ask you for the negative angles, so I'm not going to write them in unless it specifically says otherwise, okay? I always want the answer from 0. I want to go counterclockwise. Now, that would seem pretty easy, but unfortunately, it's not the only answer. There's something kind of tricky here about tan theta. Who says that tan theta couldn't have been negative 1 over negative 1? Because that also comes out to 1. We don't know if it's been simplified or not. So it's also possible that my x and my y can both be negatives. And where would that show up? That would be down here. A negative 1 and a negative 1, and a 45 and a 45 and a 90. Oops, root 2. The previous one here, I wrote root 4 in there. I don't know why I did that. Root 2. Okay. Which means that theta could have been 45, or counterclockwise from 0, I could get that far, which is 180 plus the 45, or in other words, 225. So unless I'm told otherwise, there's actually 2 answers for every single angle. every picture shows up in multiple spots because of the idea of simplifying. We don't know where the signs go. So here's our new rule for today. Because it can show up in two different spots, we have to figure out where to draw things. To do that, we're going to use the cast rule. The cast rule tells us which primary ratios and the related reciprocals are positive. So in the first quadrant, everything's positive. Every ratio, sine, costan, cosecant, secant, cotangent. In the second quadrant, sine, and of course cosecant, will be positive. In the third quadrant, tan and cotan. In the fourth quadrant, cos and secant. So in the previous question, the fact that we got tan theta and it was a positive, the fact that it was 1, tells me that I can draw it where tan is positive. That would be down here. So I could draw a picture in this quadrant. And I can also draw it where they're all positive because everything is positive there. So I'd have a second triangle there. If tan had been negative in the previous one, well, then I would have to draw in the other quadrants where it's not positive. In other words, the sine quadrant and the cos quadrant. The cast rule tells us where things are positive. And by elimination, it also tells us where things are negative. Okay, so we're going to try something. So each angle is in standard position between 0 and 360. Determine the principal angle. So cotangent, positive. Put the 1 underneath. So C, A, S, T. Where is cotangent, which is the opposite of tangent, positive? What's positive where T is? So I can draw a picture here. It's positive where all of them. I can draw a picture here. Cotangent is the opposite of tix. So instead of y over x, it's x over y. So 1, 1, root 3, root 3. And these two things are negative, which is why two negatives made a positive. Special triangles, so 30 and 30. My answer for theta is, well, the first one is this one, the nice one, 30 degrees. And the second one is what happens if I go all the way around there. So that one would be, call this theta 1, theta 2. 180 plus 30, in other words, it's 210. Again, we won't worry about negative signs unless, negative angles unless we're told otherwise. Okay, that's our big question there. Let's try the next one. Where is cos theta negative? So cos is positive here, it's positive here, which means it's negative in the other two spots, here and here. How does the cos ratio work? So 6er to x. X is negative 1, r is root 2. If those are negative 1s, these have to be 1s also, which is a special triangle. 45, 45, 45, 45. Okay, what are the answers for theta this time? Theta could be, if I start at 0 and go around to here, it's not quite 180, it's 45 short of that, which is 135 degrees. Or I've gone 45 past 180, so it's 225 degrees. Those are my two choices. I've got some more we're going to try, C and D. Okay, C, D. So looking at C, tan is positive. Tan is positive. Not in the C quadrant, yes in the all quadrant. Not in the S quadrant, yes in the T quadrant. We're talking about positives. Now this question's weird because tix, y, and x, I've never seen an x value of 3 before. That's not one of our special triangles. But I noticed that we have a radical in here. So maybe they've taken the radical and they've rationalized it. We have to unrationalize it to figure out where it came from. How do we do that? Well, we remultiply by the radical. So on top, we're going to get negative 3. On the bottom, we'll get 3 root 3. And what can happen with these 3's? Cancel each other out. And we're left with negative 1 and root 3. So tix now reads properly. Y is 1. X is root 3. We'll deal with the negatives as we need to. Oh, you know what? I did not notice the question, and tan was negative. My pictures are wrong, right? My signs won't make sense. We gotta fix this, sorry. Tan has to be negative. I had tan as positive. All right, where can tan be negative? In the C quadrant, not in the A quadrant. In the S quadrant, not in the T quadrant. Now we'll fix it. Y is negative 1. X is root 3. This one's a negative. A 3's and 30's go together. So what are my answers? My answers are 180 minus 30, which is 150. That would be the first one. And the second one would be 360 if I went all the way around, but I stopped a little bit short of that. 30 short of that, so 330. Okay, so besides the mistake that I made there, that's one of those special cases where something's been unrationalized. You know, you have one of those situations if you see a radical, but it's not the kind of numbers you're used to dealing with. Okay, letter D. Sine theta equals negative 1. Y over R. So now we're probably thinking, okay, sine is negative in the C quadrant. Not in the A, not in the S, but the T quadrant. But when I go to draw this, and this time I'm not making a mistake, okay, Y over R, I've never seen an R value of 1 before. Not for triangles, at least. But I have seen an R value when I have a special case. And this is a special case. As soon as you ever come across R being 1, or X or Y as being 0, that's special. That means it's on the circle. So let's draw the circle. Important points in the circle. When R is 1, we got 1, 0, negative 1, 0. 0, 1, 0, negative 1. I want the case where the Y value is negative 1. So look at my X's and my Y's, X and Y and X and Y and X and Y. Which case has Y being negative 1? This one. There's only one case on Y is negative 1. And that's an angle of 270. Okay, so the last two there are special cases. The other special case you could sometimes have is, what if we have something that doesn't fall into special triangles? What if we have decimals? This idea of math that we can find exact values is kind of limiting if we can't apply it to just 30s, 60s, and 90s, and 45s, and combinations of those things. What about the other ones? So, when we get something that's a decimal, and we know it's not a special triangle, okay, we're going to use the sign to draw the triangle in the right quadrant, then use the calculator to actually find the value. So the fact that this is a cos and it's negative tells me not in C, not in A, yes in S, yes in T, and I need to find this angle here. We'll call this angle X. Okay. My calculator is only programmed to find one answer. That's why I need this idea of special triangles and cast to find the second answer. How do I find my answer? I take the inverse of that decimal. Now notice I'm not using the sign. I used the sign to tell me where to draw things. I'm using the decimal to tell me my answer is 49.13 degrees. That way when I want to find theta, remember theta is measured from 0, I can say that theta number 1 is 180 minus 49.13, or 130.87. And theta number 2 is 180 plus 49.13, or 229.13 degrees. Right? I can apply these ideas to things that don't involve special triangles. I can use cast, tell me where to draw it. I have to ignore the sign when I use my calculator because my calculator doesn't want to do the sign stuff. And the fact is, it only gives you one of your two answers, right? Okay, last one. You guys try it. Given the tan theta is 2.3151, can you find me the angles theta? So, tan positive, not in C, yes in A, not in S, yes in T. Well, no, X is in here. X will be the inverse of 2.3151. If we do that on our calculators, we have to use calculators. That's not a special triangle. 66.64 degrees. That's x. But we want theta. Now the nice news is that theta, the first one, is x. Okay, it's in the right spot. It's measuring from 0. But theta number 2 is not. It's a little bit bigger than 180. It's 66.64 degrees bigger. So 246.64 degrees. Okay, now we've applied rotational trigonometry to all kinds of situations. We're going to finish off with the rest of that sheet. Hopefully at this point you're done all of it. At least when you're done this lesson. And then that's it for rotational trigonometry.